Hi everyone, let's talk about sigma donation, also called hyperconjugation. This is one factor that stabilizes carbocations, okay? And it's specifically the donation of sigma electron density from adjacent carbon-hydrogen bonds or carbon-carbon bonds into the empty p orbital of the carbocation. So there's kind of a blending of that sigma density with the empty p orbital, and it helps to stabilize the carbocations. And those atoms that are sigma donating would technically take on a slight partial positive charge. Now let's visualize this because I think it's really important to be meticulous about how we do this visually. If this is your carbocation, you want to look towards the adjacent carbon atoms, okay? Now it is going to be their carbon-carbon bonds or carbon-hydrogen bonds. That will be the bonds that sigma donate, okay? It is the adjacent carbons, carbon-carbon bonds or carbon-hydrogen bonds that will engage in the sigma donation into the empty orbital. So here there was a total of 9 bonds, okay, a total of 9 bonds. And it really depends upon how the carbocation is substituted, right? Some carbocations might only have 3 bonds sigma donate, some might have 6 bonds. But here we have what we call a tertiary carbocation, because that carbocation is bonded to 3 other carbons, hence it is tertiary. Whereas if it was bonded to 1 other carbon, it is primary, or 2 other carbons, it is secondary. And what we'll see is the more carbon attachments that you have, usually the more sigma donation that you have from those adjacent carbon-hydrogen bonds or carbon-carbon bonds. And that's the sigma density being shared, okay? Here I've drawn in kind of the orbital view. We have our carbocation's empty p orbital, and it is the electron density in these bonds here. That would be shared. That would be sigma donated into the empty orbital. And that electron donation, that kind of communal effort to make that carbon less positive, is what is stabilizing this carbocation. This is called sigma donation. We also refer to it as hyperconjugation. Be very meticulous about visualizing when you're asked to determine how many bonds are sigma donating. You visualize the carbocation. You then look at the adjacent carbons, and it would be their carbon-hydrogen bonds or carbon-carbon bonds that are the sigma bonds that are donating into the empty p orbital of the carbocation.